So we are going to start with the second Born-Haber cycle. अच्छा जी, second Born-Haber cycle. Before starting it, we should know the two enthalpy changes, and then we will draw the second Born-Haber cycle. The first thing that is standard enthalpy change of solution. Standard enthalpy change of solution. It is denoted by the symbol delta H and SOL solution. Okay. So standard enthalpy change of solution, it may be positive. Positive means having the endothermic, or it can be negative, means it's exothermic. So depending on the different compounds, it may be positive or it may be negative. Okay. Now, my dear students, what is the standard enthalpy change of solution? Let's suppose if you got an ionic compound MgCl2. Okay, this is a solid thing. Okay, so MgCl2, if you put this ionic compound in excess of water, aqueous, so what would happen? This one would form aqueous ion because this is the ionic compound. So Mg, that would form plus 2 aqueous ion, and 2Cl negative, that is aqueous ion. Okay. What is meant by this aqueous ion? You people have studied it in your A1s. Mg plus 2, this is a positive ion. You people know that water, that is a polar solvent. The oxygen of the water, that is partial negative, whereas the hydrogen, that is partial positive. Okay, so the partial negative oxygen of the water is going to attract this positive ion from all the sides, like that. So this is partial negative, hydrogens, they are partial positive. Okay, so the positive ion is surrounded by the partial negative part of the water, that is called as the is surrounded. I've just made the two water molecules, but this one is surrounded from the water molecules from all the sides. So this is called as the aqueous. Okay, just like that, this is the negative ion. The negative ion is surrounded by the water molecules as well. The hydrogen partial positive of the water is going to attract it because this is the negative ion. So negative ion would be attracted by the hydrogen partial positive from all the sides. So it means the positive and negative ions, they are surrounded by the water molecules from all the sides. Okay, so that is called as the aqueous ion. Okay, so at that time, the enthalpy change, that is called as the enthalpy change of solution. So if you people want to define it, what's the definition of it? The enthalpy change, because in the second Born-Haber cycle, we have to use these enthalpy changes. These were present in your A1s as well. But here I am going to repeat it for you so that we could be able to draw the second Born-Haber cycle. Okay. So the enthalpy change under standard conditions when 1 mole of ionic compound is dissolved in excess of water to form aqueous ions is called enthalpy change of solution. Okay. The next enthalpy change that would be used in the second Born-Haber cycle, my dear, that is the standard enthalpy change of hydration. So delta H of hydration. So standard enthalpy change of hydration. So hydration, what is the hydration? Hydration is always exothermic. It is having the negative value. What is the reason behind it? In the enthalpy change of hydration, you got the ions, gaseous ions, like Mg plus 2 gaseous ion. If you dissolve it in water, so what would happen? It would form the aqueous ions. So this thing is already present in the ions form. Okay. So this gaseous ion, when dissolved in water, it is surrounded by the water molecules from all the sides, so it will release energy. Just like that, Cl minus gaseous ion. So if you dissolve it in water, so this one is going to form Cl negative aqueous. One more thing, if you got the oxide ion, gaseous form, and if you put it into the water, in the water. So keep remember O minus 2 aqueous, that is not possible. What is the reason behind it? The reason is that basically this O minus 2, let's suppose here we got the O minus 2. Okay? So O minus 2, it is having the high charge density. So what does it do? It is going to attract the hydrogen of the water towards itself too much that it is going to break one of the water molecule and join this hydrogen with it. Okay, so if you take the O minus 2, it would react actually with water to form 2OH negative. Okay, so basically this O minus 2 and H, they would form OH negative, and this O and H, that would become OH negative. Okay, so basically when you put the O minus 2 in the water, so O minus 2 gaseous form, if you put it into the water, so what would happen? You will get the OH negative ions. So this thing would be formed. Okay, so this thing has come in the paper 2 or 3 times in the paper 4 in A2, so you should know about it. Okay, otherwise it is everything that would form the from gaseous to aqueous ion. But for oxide ion, it will form the hydroxide ion. Okay, so if you people want to define the enthalpy change of hydration, so what is its definition? The enthalpy change under standard conditions when 1 mole of gaseous ions are dissolved in excess of water to form aqueous ions. Okay. Okay, guys. Now we are going to discuss the second Born-Haber cycle. In the second Born-Haber cycle, you are being provided with you are being asked to find out the enthalpy change of solution and some of the values they are given in the question. Okay. Now, everybody just look up here that I got a compound MgCl2. Okay, this is the solid, this is the ionic compound. I want to find out its enthalpy change of solution. To find out the enthalpy change of solution, we have to use the Born-Haber cycle. Okay, so in the Born-Haber cycle, what we do, we make, first of all, the M3Cl2 at the bottom of the page like that and put a line on it. Now, in the first step, my dear, what you do, you should make it as Mg plus 2 gaseous form and 2Cl negative gaseous form. Any one of you could tell me which enthalpy change is this? Come on. Atomization. Okay, one of the students said it's atomization. I would say it is 100% wrong. Because what is the atomization? I would tell you the definition of the atomization. In the atomization, one mole of gaseous atom is formed from its element, like that. It's a it's the lattice energy, but in the lattice energy, what you take the gaseous ions and one mole of ionic compound is formed. Here, the reverse process is present. Okay, what is the lattice energy? In the lattice energy, you got the oppositely charged gaseous ions. When they come close together, they would form MgCl2 solid. So this is called as the lattice energy. So energy is released into the environment, which is called as the lattice energy. I told you in the first part of this chapter. Okay, but now if you do the reverse of it, reverse. So this is the reverse of lattice energy, and this is the endothermic process. Did you get my point or not? Yes. When oppositely charged ions come close together, having the forces of attraction, you got one mole of ionic compound, so energy is released, which is lattice energy. But up here, this is the reverse process. MgCl2 solid 2, these gaseous ions are formed. So this is the reverse of lattice energy. So reverse of lattice energy. Online students, Fatma, Yahya, Muskan, beta, did you get it?
Yes, sir.
Yes, sir.
That
Okay, my dear. Now you got the two gaseous ions. Now what should you do? You should change these gaseous ions one by one into aqueous ions. So first of all, what I'm going to do, I'm going to write Mg plus 2 aqueous and 2Cl negative, that is gaseous. It is not changed. Okay, I just changed. So this is actually the delta H of hydration of Mg plus 2. Okay, Mg plus 2. Because this one changed from gaseous to aqueous, this remains from gas to gas. This is exactly same. Okay, now change this one into aqueous. So write up here Mg plus 2. Write this thing as it is, aqueous, and this one you should write 2Cl negative aqueous. Okay, so this is delta H of hydration of Cl negative. But if you look up here, there are the two Cl negative, two. So you should multiply this one with 2. Okay? Now, this ionic compound, if you change it into the aqueous ion, so this is called as the enthalpy change of solution. So you have to find out this one. Okay, so now your cycle is going to start from a place where you got the tail. So this is, my dear, the starting point. Okay, and your end point, that is this one. This is the end point. So from start to end, you got this one, delta H of solution. That is equal to, the second root is this one. So reverse of lattice energy plus hydration of positive ion plus hydration of negative ion. And here the negative ion contains the two atoms. So you should multiply it with 2. So you should learn this formula as well. Delta H of solution is equal to reverse of lattice energy plus hydration of positive ion plus hydration of negative ion. These two shouldn't you write in the formula. Okay, you should see how much negative ions are present, then you should use this formula. Okay, I have just write these two according to this one, MgCl2. Okay, so now, my dear students, we are going to discuss some of the past paper questions. Okay, guys, so I'm going to share a screen with you people. So, giving you a question, so you people are supposed to do the answer. Okay, so let me Give you the question. Okay. It's the question number B, part 1 and 2. So let's start. Question number B, part 1 and 2. Okay, guys. So I'm going to do it for you. The first question so that you people could understand it. Have a look up here. Uh, if you look, this is MgOH twice. So MgOH twice, it has one Mg plus 2 and OH there twice. So you got two OH negative. Okay. So here we should write down the formula. We have to calculate the delta H of solution. I told you delta H of solution is equal to reverse of lattice energy plus hydration of positive ion plus hydration of negative ion. Okay, so if you look the values for the values for the magnesium are these one. So if you see the lattice energy, it is minus 2993. So this minus is separate. So minus and then minus 2993. Okay, and plus then the hydration of positive ion. So positive ion hydration is minus 1890, and then plus you got the two negative ions 2. So here we should write 2 and the OH minus signs, that is minus 550. So if you solve it up, my dear, let me know what the answer you got. Plus 3. It's perfect. It's 100% perfect. Now do the second one for strontium. Same thing. How much? Perfect. हो गया यार. Padma, Muskan, and Yahya, beta, did you get it? How to do it?
Yes, sir.
Yes, sir.
Come on, do the next one, strontium one.
Sir, I got
Yeah. You got
minus 4,981.
the second one, strontium one. Strontium hydroxide, Fatma. I think we did little bit beta. These are the strontium values, beta. So the same formula is used up here. So delta H of solution, that is equal to reverse minus, and the lattice energy value is this one, minus 2467, and plus hydration of positive ion. So positive ion is this one, minus 1414, and then plus strontium hydroxide contains the two hydroxide ions. So 2 times this is also minus 550. So if you solve it, you will get the answer minus 47.
Yes, I got minus 47. I forgot to put the minus before the lattice energy.
Okay, that's fine. Okay, my dear students, everyone got it? Can I move to the next question?
Yes.
Okay, do this question, please. Question number 2. Hurry up. Okay, one of the student got minus 225. Now, who did it? Sorry, I did not see the name. Who was that?
Sir, me.
या आपने भेजा मैसेज
जी सर.
ये कहीं से देख के भी नहीं बता दिया या
नहीं नहीं सर, फॉर्मूले को ही बस ये थोड़ा सा चेंज किया है.
अच्छा चलें जी सबसे पहले साइकिल ड्रॉ करते हैं वी आर गोइंग टू ड्रॉ द साइकिल सो लेट्स स्टार्ट विद इट फर्स्ट ऑफ ऑल माय डियर स्टूडेंट्स यू शुड राइट कैल्शियम नाइट्रेट CaNO3 whole twice this is a solid thing okay then you should change it into gaseous ions so calcium plus 2 gaseous form and 2 nitrate that is gaseous form as well. So this is the reverse of lattice energy. Okay. Now change the calcium into the calcium aqueous. So calcium plus 2 aqueous and write nitrate as it is 2NO3 minus gaseous form. So the hydration of the calcium its value is given in the question minus 1650. Okay, in the second part, change nitrate into the aqueous form. So calcium plus 2 aqueous and then 2 nitrate NO3 minus aqueous. Okay, so its value is minus 314, minus 314. But if you look up here, you got the two nitrate ions. So two nitrate ions, two times. Now change this one into this one. So this one would be delta H of solution, and delta H of solution is given minus 19. Okay, so now this cycle is going to start from here. This is the starting point, and this is the end point. Okay, so from start to end, we got minus 19, that is equal to reverse of lattice energy plus minus 1650 and plus 2 times minus 314. Okay, so if you solve it up, you will get the answer minus 2259, is it?
Yes, sir.
Yes, sir.
Okay, that's fine. Now, my dear, giving you one more question. This time you shouldn't stuck and you should do it. Okay, do this one, please. Yes, anyone? G क्या है? Plus 377. Plus 377. Okay.
I got minus 377.
Not minus beta, it's positive here. Because minus would be cancelled with the minus. Because the reverse, if you look, you got the minus lattice energy. So you got minus 377. So minus minus would be cancelled. So that is why the answer would be positive. Did you get it?
Yes, sir.
Okay, guys, so this is the second Born-Haber cycle. So now what I suggest you, I've sent you one of the worksheet and sending you one more worksheet. So both worksheets, my dear, you should find out the question of the first Born-Haber cycle and the second Born-Haber cycle.